Hello everyone, welcome to Saimedha Koti, Hyderabad. In this session, I would like to discuss about gunshot bits in transformer for Genco AE exam. Let's start from the question number 1. The question 1 is a short circuit test on a single phase transformer gave following data 30 volts at 50 Hz, 20 amps, power factor equal to 0.2 lag. The short circuit test is performed on 30 volts 25 Hz. Then the short circuit current option 1 decreases at a power factor less than 0.2, increases at a power factor less than 0.2. Option 3 increases at a power factor greater than 0.2. It decreases at a power factor the greater than 0.2. So, short circuit test of the transformer, the test of transformer is conducted. So, we have some short circuit test data. So, that is 30 volts the at 50 Hz frequency, 30 volts the at 50 Hz frequency. Then what will happen? See here, 30 volts at 50 Hz, the 20 amps, okay, power factor the is equal to 0.8, okay, lagging, the 0.8 power factor lagging. So clear my point. So 0.8 power factor lag. And same the initially the test is performed on 30 volts the at a power factor, okay, at a frequency 25 Hz, and we have then the current and then what will happen in the short circuit current and power factor, short circuit power factor of the transformer. So by using this test data, we conclude that the voltage is a constant, okay, voltage is a constant and frequency is reduced below its rated value. So if the short circuit test is conducted by keeping voltage constant and frequency is reduced below its rated value, then what will happen in the short circuit current and power factor of the transformers. So by keeping the voltage constant, by keeping voltage, supply voltage is a constant and frequency is reduced, okay, this frequency the reduces less than the rated values, the reduce the F rated, so then what will happen? So what will happen in the short circuit current of the transformer and power factor under short circuit conditions. So how do we get the short circuit current and what is the formula to find out short circuit current of the transformer? So this short circuit current can be written as ISC is equal to the ZSC, VSC, voltage under short circuit condition, divided by impedance under short circuit condition. So this impedance can be written as the VSC, the ZSC is equal to RSC plus J, the XSC value. Therefore VSC divided by RSC plus the J, the XSC can be written as 25FL. So this one is the impedance for it. So from here, therefore we can get ISC is equal to the VSC divided by RSC plus the J, the 25FL. So by keeping voltage constant and frequency is reduced, by keeping the voltage constant and the frequency is reduced below its rated value, what will happen? Short circuit current of the transformer increases. So what I conclude? Therefore the short circuit current of the transformer increases. Now what about this power factor, short circuit power factor? So this one is for example, it is a RSC, the impedance resistance under short circuit condition and reactance under short circuit condition, and this one is the impedance under short circuit current. So this is the theta SC. From this the triangle, so we can get the short circuit power factor is equal to, so this is the ratio of RSC divided by the ZSC values, impedance, the short circuit power factor is equal to RSC divided by Z. So where ZSC can be written as cos theta SC is equal to the RSC divided by RSC plus J, the X, this one is the J, the XSC, so that is equal to 2 phi FL. So now this is a 2 phi FL value. So now, so how do we get this, what is the changes in this short circuit power factor? The resistance is the independent of voltage, and this what is the independent of the frequency changing. Now only frequency is reduced, okay, below its rated value, that this short circuit power factor will be increased. So therefore what I conclude, power factor of the transformer under short circuit current will be increased. So short circuit current increases at a power factor greater than the 0.2. So option the 3 is the correct for this question. Okay. And next one, let us solve the question number 2. Question is, open circuit test on single phase transformer gave following test data: the 230 volts at 50 hertz, the 2 amps, power factor is equal to 0.2 lag. So if open circuit test is performed on 230 volts 45 hertz, then no load current, option 1, that decreases at a power factor greater than the 0.2, that decreases at a power factor less than 0.2, increases at a power factor greater than 0.2, the increases at a power factor less than 0.2. So open circuit test is conducted. So we have the test data, the initially 230 volts, okay, at 50 hertz, the at 50 hertz frequency, 230 volts at 50 hertz, the 2 amps, okay, power factor is equal to 0.2 lag. So this is the power factor. Now same test is conducted on a same transformer. So we have a test data 230 volts, the at 45 hertz. So 45 hertz. Now what will happen in the short open no load current and power factor under no load conditions, power factor of the transformer under no load condition. So now in this case what we conclude, so by keeping the voltage constant, okay, here voltage is a constant but frequency is a reduced, okay, this frequency is reduced to below its rated value, okay, this is the frequency of the transformer that decreases below its rated values. By keeping the voltage constant, frequency is reduced, then what will happen in the no load current of the trunk? So now we know by keeping voltage constant, okay, during operation, okay, this one is during the operation of transformer, so flux density B maximum, the directly proportional to V1 by the F ratio. The by keeping voltage constant, okay, frequency reduced to below its rated value, the flux density of the core increases. So increase in the flux density, the transformer core goes into the deep saturation. The transformer core goes into deep saturation, which demands high magnetizing current. So now due to which what will happen, the magnetizing current of the transformer increases. So now by using the statements we can say that the B maximum is not constant. So when B maximum is not constant, then what will happen? So when the B maximum is not constant, the hysteresis loss, okay, directly proportional to the applied voltage V power 1.6 and inversely proportional to the F power 0.6. And what about eddy current loss? Eddy current loss directly proportional to the V1 square. So by keeping voltage constant, okay, frequency only reduced below its rated value, the hysteresis losses will be increased. So increase in the hysteresis losses here, but what about eddy current loss? The eddy current losses remains constant. So increase in the hysteresis losses, the increases iron losses. The increase in the iron losses, iron loss component of the current will be increased. Now here two currents are there. One is a no load current of the transformer this is the no load current is equal to the vector sum of magnetizing current plus iron loss component of the current. So increase in these two currents, okay, increase in the magnetizing current and also iron loss component of the current, the no load current of the transformer will be increased. So no load current of the transformer increases means these two options will be cancelled, only 3 or 4 are possible. But we need to find out the power factors, what will happen in the power factors part. Now for this one we need to draw the vector diagram. So this is the applied voltage. Now let us assume this one is the phi 1, primary flux of the transformer. Now initially this is the magnetizing current I mu 1 and this one is the iron loss component of the current. So vector sum of these two you will get the no load current I naught and this angle is a theta naught. But this current is increasing, okay, this magnetizing current is increases. So rate of rise of the magnetizing current, okay, this rate of the rise of the magnetizing current is more as compared to the rate of rise of iron loss component of the current. So due to which what will happen, this increases very small, this one is increasing more. So now due to which, so now this angle theta naught is increased. So increase in the theta naught, okay, decrease as the cos function, cos theta naught is decreases, so which is less than 0.2. So answer for this question, the no load current increases at a power factor less than 0.2. So option the 4 is correct for this question, okay. And next one, let us solve the question number 3. Two transformers operating in parallel have different quality of their leakage impedances for a load power factor 0.8. So both would operate at a power factors less than 0.8. So both would operate at a power factors more than 0.8 and both would operate at a same power factors. One would operate at a power factor greater than 0.8 and other would operate at a power factor less than 0.8. So what will happen here? So X by R ratios, okay, X by R ratio of transformer A, okay, this transformer A, is the greater than the X by R ratios of the transformer B, then what will happen here? So when X by R ratios are greater than the transformer A and transformer B, so then what will happen? So here let us take tan inverse of, okay, tan inverse of the X by R ratios of the transformer A is a greater than the X tan inverse of the X by R ratios of the transformer, okay, B. So now this is a theta A is a greater than the theta B. So now this cos function what will happen? The cos theta A less than the cos theta B. So now this is a power factor of, okay, this power factor of the transformer A and this one is the power factor of the transformer B. So now transformer which has high X by R ratio will operate less than the load power factor. The transformer which has, what I conclude, the transformer which has a high X by R ratio, I X by R the ratio will operate, okay, this is the that will operate at a power factor, okay, operate at a power factor the less than the load power factors, okay, load power factor. So whatever the load power factor 0.8 or 0.6 or whatever it may be. And next one, the transformer which has a high X by a low X by R ratio, the low, okay, X by R ratio, so will operate, okay, operate at a power factor, so at a power factor greater than the load power factors. So for example, your load power factor is 0.8 and 0.8. So now one transformer would operate at the greater than the 0.8 power factor, other transformer operate at less than the 0.8 power factor. So that option the 4 is correct for this question, okay. Let us solve the question number 4. A 400 volts upon 100 volts 10 kVA 2 winding transformer is reconnected as auto transformer across suitable voltage source, the maximum rating of such a transformer could be option 1 50 kVA, option 2 15 kVA, and option 3 12.5 kVA, and option 4 8.75 kVA. The given rating of ratings of the two winding transformer, ratings of the two winding the transformer. So we have the voltage rating and the power rating. So this voltage rating is a 400 upon the 100 volts, 10 kVA transformer. So now by using this rating, so this two winding transformer is connected in the 4 ways, this connected in 4 ways of auto transformer. The first one, the here case 1, the one is consider as a case 1. So connected as a auto transformer with the series additive polarity. So with the series here series additive polarity, the polarity of supply voltage with additive polarity connection, polarity connection. So first case, this case. So here consider this one is the supply voltage. So we have a series additive polarity connection. Otherwise, I will make a table. Listen. So we have two types of the connection. One is the series additive polarity, polarity nature, and second one is the subtractive polarity nature, subtractive polarity of auto transformer and series polarity of the auto transformers. Now in this case we have two supply voltages. The first one, in this first cases consider supply voltage is a high voltage. So now consider V1 is equal to the 400 volts. So when it is connected in the series additive polarity, the V2 is equal to 400 the plus, this one is a series additive polarity nature. Now this is the, we can say that E1 the and this is the V1 by either E2. When these two are connected in series additive polarity connection, the V1 plus E2 the is equal to this is a the 400 plus 100 the equal to 500, this is the 500 volts. And if it is connected in series subtractive polarity, V2 will become. So now if the V1 is equal to 400, then V2 is equal to 400 the minus 100 the equal to 300 volts. Now if it is a 400 and next one, the if the supply voltage the V1 is equal to the 100 so volts. Now if it is connected in series additive polarity, the V1 plus V2 is equal to, so series subtractive additive polarity. So then what will happen? Supply voltage is the 100 the plus 400 the equal to the 500, and here V2 is equal to the 400 minus the 100, it is equal to the 300. So this one is the also the subtractive polarities, the 400 minus 100 that is equal to the 300 volts. Now what about the transformation ratio? Here K is equal to always, transformation ratio K is equal to the low voltage of auto transformer divided by the high voltage of auto transformer. So now K of, in this case, low voltage is the 400 divided by the 500, this one is the 500, it is equal to 4 by 5. Now here K is equal to low voltage of auto transformer. So 300 divided by the 400, it is equal to 3 by 4. Now here K is equal to, so low voltage is 100 the divided by 500, 500 the equal to 1 by 5. The low voltage of auto transformer, so 100, so divided by, so now this is the 300, so it is equal to 1 by 3. So now if it is K is a 4 by 5, so then what will happen? So now here K is equal to, in this case let us calculate. So if the K is equal to KVA rating of auto transformer is equal to, so what is the formula to find out KVA rating? The KVA rating of auto transformer is equal to 1 by 1 minus K times of the KVA rating of the two winding transformer. This is the formula. So K is the transformation ratio. So therefore 1 the divided by 1 minus 4 by 5 the into 10 kVA. So this is the 4 by 5. So it is equal to the 50 kVA. So we got, so first cases is the 50 kVA. Now again the let us calculate KVA rating of auto transformer is equal to, so 1 by 1 minus 3 by 4. So that is equal to multiplied by 10. So equal to 40 kVA. So here we get the 40 kVA. Now here in this case KVA rating of auto transformer is equal to, so that is a 1 by 1 minus 1 by 5 the into 10. So it is equal to 4 the 5 by 4. So 50 by 4. So 12.5 kVA. So now this one is the 1 kVA rating of auto transformer is equal to, so 1 by 1 minus 3. So multiplied by the 10. So now it is equal to the 15 kVA. So like this. So which is the maximum kVA rating? So we don't know. So whether it is, what is the voltage rating of auto transformer? That's why, so we need to connect in the suitable voltage source. So here I have taken applied voltage. Supply voltage is a supply voltage of auto transformer. Consider this one. The initially 400 volts. These are connected in series are to polarity and subtractible. So in which connection, if the supply voltage is a 400 volts and connected in series are to polarity, so then we will get maximum the rating of transformer. So that is a 50 kVA is the right answer for this question. And next one, let us solve the question number 5. In an auto transformer of voltage ratio of V1 by V2 and V1 greater than the V2, the fraction of the power transferred inductively. So mention that ratio voltage is given. So voltage ratio of the ratio of auto transformer is given. Ratio of the auto transformer. So that is a V1 by the V2. So and also mention that the V1 is greater than the V2. So now how do we get K of transformation ratio of the auto transformer is equal to the low voltage of auto transformer the divided by high voltage of the auto transformer. So what is the low voltage of auto transformer? So this K is equal to the K of auto transformer is equal to, so which one is the low? So V2 divided by the V1. Now we required KV rating of the induction power. So what is the formula to find out the induction power? So induction power is equal to the 1 minus K times of the input power. Okay, this is the input power of the auto transformer. So now the fraction of the power transferred inductively. So therefore induction power the divided by the input power of the auto transformer. So input power of auto transformer so is equal to 1 minus K. So let us substitute 1 minus, where K is equal to V2 by V1. So V1 minus V2 divided by the V1 value. So V1 minus V2 divided by V1. So fourth option is the correct for this question. And next one, let us solve the question number 6. A 20 kVA 2300 volts 230 volts 2 winding transformer is to be used as an auto transformer to give the 2300 volts upon 2530 volts. Its rating will be option 1 the 200 kVA with conducted kVA is equal to 20, the 200 kVA with conducted kVA is equal to 180, the 220 kVA with the conduction kVA is equal to 20 and 220 kVA with conduction kVA is equal to 200. So here these are the 20 kVA, the 2300 upon 230 volts 2 winding transformer is to be used as a auto transformer. So this is for the auto transformer, these two are for the 2 winding transformer. Now let us, by using this auto transformer voltage rating, so transformation ratio of auto transformer is equal to the low voltage of auto transformer divided by high voltage of auto transformer. So what is the low voltage of auto transformer? That is equal to, so 2300 okay, divided by the 2530 okay, 2300 divided by, so 2530. This is the transformation ratio of the auto transformer. So after getting the transformation ratio, how to find out KVA rating of auto transformer? So this KVA rating of auto transformer is equal to the 1 by 1 minus K times of the KVA rating of the two winding transformer. So this is equal to 1 by 1 minus, okay, this one is the 1 by 1 minus the K is equal to 2300 upon the 2530. So 530 multiplied by the 20 kVA. The simplify this, so this value is equal to, so 2530 divided by the 230 multiplied by the 20 kVA. So by solving this we can get the 220 kVA. So here this kVA rating, induction kVA of auto transformer, the is equal to the induction kVA the of auto transformer. Okay, this induction kVA of the auto transformer is equal to, so kVA rating of the two winding transformer, so that is equal to the 20 kVA, but we require the conduction kVA. So how do we get the conduction kVA? So this conduction kVA of auto transformer is equal to the input kVA or kVA rating of auto transformer, the minus okay, induction kVA. So this induction kVA of auto transformer, so input kVA of auto transformer, this induction kVA of auto transformer, so 220 kVA minus 20, so it is equal to 200 kVA. So what is the answer for this question? 220 kVA. So with conduction kVA is equal to 200. So option 4 is correct for this question. Let us solve the question number 7. The question is 10 kVA single phase transformer has core losses of the 60 watts at rated voltage and ohmic losses of 85 watts. The rated current, its a maximum efficiency at unity power factor is option 1 98.81%, 98.52%, 98.02%, 98.59%. So given that the rating of the two winding transformer S is equal to, the S is the given rating or power rating, the is equal to 10 kVA. So now next one, we have the 10 kVA of the rating, and also mention that iron losses. So iron losses are denoted by the Wi, it is equal to 60 watts, and at rated ohmic copper losses, okay, this is the copper losses of the transformer. So this copper loss, the is equal to copper losses is equal to, so it is denoted by WCU, it is a 85 watts. Now we required maximum efficiency of the transformer, the at unity power factor load, okay, at unity power factor load. So what is the formula to find out the maximum efficiency of the transformer? The percentage, okay, maximum efficiency of the transformer is equal to, so this XM, the S cos theta, the divided by the XM, the S cos theta, okay, S cos theta plus 2 times of the iron losses multiplied by 100, where S is the rating of the transformer, cos theta is the power factor, where XM is a fraction of the load. Okay, in this case, very important point, the XM, so this is nothing but the fraction of the load at which the fraction of the load, okay, at which the maximum efficiency occurs. Okay, this maximum efficiency occurs in the transformer. XM is a fraction of the load at which maximum efficiency occurs in the transformer. So how do we calculate this Xm value? The Xm is equal to under root of the iron losses divided by full load copper losses. So therefore Xm is equal to, so this under root of iron losses of the transformer is equal to the 60 divided by, so this one is the 60 divided by 85 watts. Now therefore Xm, let us calculate. So this Xm value, so this Xm is equal to 0.8401. So after getting this Xm value, so now let us calculate the percentage efficiency of the transformer. So therefore 0.8401, so multiplied by the S is the 10 into 10 to the power of 3, so 10 kVA rating, so multiplied by unity power factor, so that is a unity. So therefore 0.8401 the into 10 to the power of 3, so plus 2 times of iron losses, 2 times of iron losses, the 2 into 60 multiplied by 100. So now by solving this you can get the percentage efficiency of the transformer. So now let us calculate. So this one is, so this by solving this we will get 98.59%. So answer is 98.59% is the right answer for this question. And next one, let us solve the question number 8. A 3-phase delta star transformer has the secondary to primary turns ratio per phase of the 5. So this is the per primary voltage of the 400 volts, the secondary voltage would be. So given that 3-phase the transformer, so delta star the 3-phase transformer, and in the delta star 3-phase transformer, so secondary voltage, the primary applied voltage is given, so that is equal to the 400 volts, and this one is a, and another one is 5 transformation ratio is given. So now this is the A is equal to 1 by 5. So primary to turns ratio, secondary to primary turns ratio is equal to 5. So therefore this A is always, so it is the N1 phase divided by the N2 phase. So therefore N1 phase is equal to 1 by 5 all. So now what about per star, the delta star 3-phase transformer? So this is the E2 is equal to, so V2L is equal to, the V2L is a root 3 times of the V1L. So this is the V1L by the A. So now this one is a, the root 3 into, so what is the applied voltage? So it is equal to 400, so divided by 1 by 5. So root 3 into 400 multiplied by 5. So now this value is equal to root 3 into, so now this is a 2000. So 2000 multiplied by 400. So value is equal to 3664 volts. So answer for this question 3464 volts is the right answer for this question. And similar question, a 3-phase star delta transformer, a secondary to primary turns ratio is given. Secondary to the primary turns ratio. So given that the N2 phase by N1 phase the is equal to 5. So therefore the A is equal to N1 pace divided by the N2 pace, it is equal to 1 by 5, and for a primary voltage of 400 volts, okay, this one is the V1 is equal to the 400 volts. Now which transformer? Star delta 3 phase transformer. So per star okay delta 3 phase transformer, so how do we calculate secondary voltage? Okay, let suppose in this case, suppose here per star delta 3 phase transformer, so V2L is equal to, so this is a the V1L divided by the root 3 divided by root 3 times of A. So V1L is equal to 400, so divided by root 3, so multiplied by 1 by 5. So 1 by 5 is equal to, so 2000 divided by the root 3. 2000 divided by root 3 is equal to 1154.7 volts. So answer is option B is the correct. And next one, let us solve the question number 10. For a 3-phase star delta transformer as the primary to secondary to primary. So mention that secondary to primary turns ratio. So that means given here the secondary to primary turns ratio, the N2 pace by N1 pace, so N1 pace is equal to the 5, but we required A. So where A is equal to the primary pace turns ratio divided by the secondary pace turns ratio, it is equal to 1 by 5. After getting A, so then the also mention that primary line current I1L is equal to the 10 amps. So now what about the secondary line current? I2L is required. So type of the connection is the star delta transformer. So per star okay delta 3 phase transformer. So per star delta 3 phase transformer, I2L is equal to root 3 times of the AI1L. So now root 3, the A is equal to 1 by 5 and I1L is equal to 10. So by solving this we will get 1.663 times of the amps. So now this one is the answer for this question. So 1.663 times of the amps for this question. Answer is option the C is the correct. Got it? So this was the discussion about my 10 questions in the such as gunshot bits in the transformer for Genco AE exam. And also I would like I will share the information about the Genco AE and AE exam. So we are providing online and offline coaching for AE exam. So online coaching kosam, so అది ఇంకా ఓన్లీ 2 days ఆపరే ఉంది. సో మీరు ఇప్పుడే తీసుకోవాలనుకుంటే ఆ 2 daysలో మీరు తీసుకోవాలనుకుంటే దాని ఫీ స్ట్రక్చర్ ఎలా ఉంటుందంటే సో 5900 రూపీస్కే. సో దీంట్లో మీకు కంప్లీట్ వీడియో లెక్చర్స్ అన్ని సబ్జెక్ట్స్ సిలబస్ ఎంత ఉందో అంటే న్యూ సిలబస్ యాడ్ అయిన సిలబస్ ప్లస్ ద కంప్లీట్ వీడియో క్లాసెస్ ఉంటాయి, ఆ వీడియో రికార్డింగ్ క్లాసెస్ ఉంటాయి. దాంతోపాటుగా మీకు పీవైక్యూస్ కూడా ప్రొవైడ్ చేస్తాం. అంటే జెన్కో, ట్రాన్స్కో, డిస్కమ్, ఏడబ్ల్ఈ all PYQ questions and also GATE PYQ question, ESC PYQ question, UPSC PYQ question. ఇదే ఈ క్వశ్చన్స్ కాకుండా మీకు అడిషనల్గా ద స్టాండర్డ్ టెక్స్ట్ బుక్స్ PYQs కూడా ప్రొవైడ్ చేస్తున్నాం. సో ఈ కంప్లీట్ కోర్స్ మీకు ఎంత అంటే ఆన్లైన్లో 5900 రూపీస్ ఓన్లీ. అదే మీరు ఆఫ్లైన్ బ్యాచెస్ కూడా ఉంది. సో ఈ ఆఫ్లైన్ బ్యాచెస్కు సో ఆల్రెడీ బ్యాచ్ అనేది సో స్టార్ట్ అయింది, 3-4 days అవుతుంది. సో 3-4 days అయినా కూడా ఇంకొక 4-5 daysలో మళ్ళీ ఇంకొక సబ్జెక్ట్ స్టార్ట్ అవుతుంది కంప్లీట్గా. సో క్లాస్ టైమింగ్స్ ఏంటంటే 6 AM టు ద 8 PM వరకు ఉంటుంది. సో క్లాస్ మధ్యలో అంటే ఆఫ్టర్నూన్ సెషన్ కానీ సో బిఫోర్ లంచ్ దెర్ ఈజ్ అ స్పేస్ ఫర్ ద రివిజన్ ఆఫ్ ద క్లాస్ అండ్ టెస్ట్ ఆల్సో ఎవ్రీడే టెస్ట్ ఉంటుంది. సో ఈ ఆఫ్లైన్ ఫీ స్ట్రక్చర్ ఏంటంటే ద 36,000 రూపీస్, బట్ so we are giving 50% discount. Okay, by 50% discounts, so for 18,000 only, so we will get a coaching of offline for Genco AE, the Telangana Genco AE exams. Okay, so మీరు ఆఫ్లైన్ తీసుకోవచ్చు లేదా ఆన్లైన్ తీసుకోవచ్చు. ఒకవేళ నువ్వు ఆఫ్లైన్ తీసుకుంటే ఆన్లైన్ కోర్సెస్ కూడా కంటెంట్ ఫ్రీ ఉంటుంది. సో ఇంకా నువ్వు ఆఫ్లైన్ క్లాసెస్కి వెళ్ళడం వల్ల సో ఈ క్లాస్ యొక్క రికార్డింగ్ క్లాసెస్ అంటే క్లాస్ రూమ్లో రికార్డ్ అయిన వీడియోస్ కూడా యాప్లో మీకు షేర్ చేస్తాం. మీకు స్పేస్ గేట్ అనే యాప్ డౌన్లోడ్ చేసుకోండి. సో ఈ స్పేస్ గేట్ యాప్లో సో కంప్లీట్ ఉంటాయి. ఇఫ్ యూ హ్యావ్ ఎనీ ఇన్ఫర్మేషన్, ఇఫ్ యూ వాంట్ టు ఎనీ ఇన్ఫర్మేషన్ అబౌట్ దిస్, ప్లీజ్ కాంటాక్ట్ దీస్ నెంబర్స్. సో మీరు నెంబర్స్ కాంటాక్ట్స్ అయితే మీకు కంప్లీట్ ఇన్ఫర్మేషన్ వస్తుంది. సో ఈ ఆఫర్ మాత్రం 2 డేసే ఉంటుంది. ఈ 2 డేస్లో మీరు యూటిలైజ్ చేసుకోవాలనుకుంటే సో ఇది కంప్లీట్ తర్వాత దీనికి ఎక్కువ ఛాన్సెస్ అయితే ఉంది. సో ఐ హోప్ యూ గాట్ ఇట్. థ్యాంక్ యూ వెరీ మచ్. అండ్ ఆల్సో ప్లీజ్ డూ like this video and share this information to our friends and subscribe our channel. Thank you very much.